Okay, so what have we done already? Well, we did some natural log stuff. We took the integral of 1 over x, and what did we learn about the integral of 1 over x? Why did that cause problems?
Zero in the denominator?
Yeah, we ended up taking, if you followed the basic rule for taking integrals, we ended up with a 0 in the denominator. So then we developed a conflict here because mathematically there shouldn't be a value because you have a 0 in the denominator which negates everything. However, when we looked at the graph of 1 over x, we could see that there was a definite area under that curve. And so we used that information to come up with the integral of 1 over x, and then we introduced the term e, and we did all kinds of fun stuff. Where did e come from, by the way? No, not that. Not how to regurgitate all the numbers of e, but where did e come from?
Isaac Newton.
I'm sorry?
Isaac Newton.
No.
Is it the other guy?
I think you're misunderstanding my question. The other guy. Yeah, you're right. It was that other guy.
Okay.
I don't know which one, but
It comes from.
what is the significance of e?
Well, E comes from the alphabet. It's between D and F.
Absolutely.
Yeah.
I can already tell you're gonna rock the Andrea.
E is the base for the natural log.
Correct, but where does the number e come from? Wait, let's all talk at the same time. Ready, go.
I love lamps.
From where to where?
From
1 to 2.
1 to e, correct. Okay, so it's the significance of e is that it's a number on the x-axis going from 1 out to e. And why is that number significant? What's true about the area under the curve, Eric?
1.
It equals 1, correct. So if you remember the shape of 1 over x, that's the spot where it's going to guarantee the area under the curve is equal to 1. And you're right, it is the base of the natural log. Natural log is the same thing as log base e, all that other fun stuff. But from a calculus standpoint, that's where it comes from. Okay, so we're going to go backwards today. We're going to talk about log rule and some integration. We're going to integrate some trigonometric functions. So we have, I think, 4 trigonometric integrals that seem kind of contrived. We're going to come up with the big 6. Sine, cosine, tangent, cotangent, cosecant, and the other one that I forgot. And then you should be able to balance a checkbook. Do you even know what a checkbook is?
Yes.
How many people know what a checkbook is?
This guy.
For those of you that have your hands up in the air, how many of you can balance a checkbook?
I used to be able to.
Great. Used to past time.
Personal finance.
Okay, good. I would imagine that's going to be irrelevant for you when you are all adults.
Balancing check.
Yeah, because I mean, I'm older and I still write 2 checks a month at most.
Oh, people do it with their debit cards.
Correct. Debit cards and credit cards and all those fun things.
Or you just live at home.
Excellent answer. You're going to stay in the basement and never come into the sunlight. So we talked about taking the integral of 1 over x, and we got the natural log of x. So now we're going to go the other way. If you take the derivative of the natural log of x, you get 1 over x. And then remember this rule here, the u prime over u, which was, you could forget about the left-hand side. If you just remember the right-hand side, you'll be good to go. Why is there an absolute value in there?
Log of a negative number.
Good, you can't take the log of a negative number. So then, going backwards, we did this already. 1 over x is the natural log of the absolute value of x. 1 over u is the absolute value, natural log of the absolute value of u. And again, those absolute value bars are important because it guarantees that you're not trying to take the natural log of a negative number. And then little things like the plus c. Why is there a plus c there?
It's integral.
I'm sorry?
Because it's an integral. And when you take
It's an indefinite integral, correct.
Yes.
There is no numerical value there. That doesn't represent an area under a curve. All right, find that. Okay, we good? No? Am I talking to myself? We're good. You got that? That's not bad. Yeah. So, move the 2 out in front. Then take the integral. Okay. Now, watch me get all fancies in my pantsies. Why did that happen? Other than I clicked a button. Good. Where'd the absolute value go, Claire?
If you're squaring a number, it's gonna turn out positive.
Beautiful. Okay, which is what that paragraph says. Is there anything wrong with this statement? Absolutely not. But again, if you want to get fancies in your pansies, you can move the 2 up in front using the log properties and lose the absolute value. They're both correct.
Wait, where did the 2 go?
Remember the property of a logarithm, the number in front can become an exponent, and when you square something, it's going to always be positive, so you can drop the absolute value. Okay, easy? Good. Not so easy. What are you going to do?
Cry.
Good. Cry is one option.
UDU.
UDU. That would be a more sound approximation. Approach. Not that crying isn't somewhat cleansing and cathartic. Dan, what are you using for U?
Oh, X to the 4th with 3x.
Outstanding. Question, was a mistake. Okay. Can you mark the absolute value? No?
Because of 3x.
Oh, okay. Nifty. So, we're good to here? The question I just asked Matt, can I drop the absolute value bars there? Like I did in the last problem?
Did you get 1?
No, because x to the 4th plus 3x is not always going to be a positive value. If, for instance, x was negative 1/2, we would have a problem. Okay, not so bad, right? Right, good. Of course it's going to get worse. Did you expect anything else? Okay, if a rational function has a numerator greater than or equal to that of the denominator, splitting the fraction may reveal a form which you can apply the log rule. Okay, this is another approach to a complicated problem. So for instance, I have this function. Notice that a UDU won't work here because regardless of what I choose for U, when I get done doing my substitution, I'm going to have x's and u's, which we know already is bad. So what you can do, and this doesn't come up a lot, but you can split the fraction. And I split the fraction this way. I grouped the x squared plus 1 together on the top so that that reduced to 1. Then I left all the other stuff over there on the right. Is it safe to assume you can all take the integral of 1? I guess I expected a resounding yes, but can you take the integral of 1?
Yes.
Okay, just checking. How you going to take the integral of x over x squared plus 1?
Could use TU. I mean, UDU.
U to u. And what would u be, Mason?
X plus 1.
Yeah.
back a sec. On the slideshow, please.
Oh, sure. Would you want that?
Yeah.
How are you going to know when to use splitting the fraction? You're pretty much not. It just becomes another weapon in your arsenal, so that when you run out of ideas on how to take an integral, it's something else you can try. And it pretty much only works when the two parts are then integratable. If that's actually a word. Okay, so then yeah, two separate integrals, the dx, and then going into one to u, and then that's just x, and then, you know, so, okay. That last sentence, because we're doing integrals, what has always been true is still true, and that if you're not sure if that's the answer, take the derivative of it. You should end up back where you started. How do you take the derivative of the natural log of something? Come on. It's gotta be burned into your brain.
Prime over u.
U prime over u, correct. Okie dokie. Differential equations. Remember, differential equations are going to get us to the specific solution, not just the C term. So we'll start with that bad boy. Now, what I'm going to show you, you might not want to write down. We're eventually going to get to a theorem that will help you. If you are a memorizer, then don't write anything down. If you want to be able to derive things, and I'm not saying one is better than the other, then write stuff down. But I'm going to solve that differential equation. Okay, so, like we talked about, to solve a differential equation, you split the differentials, move the dx to the other side, take the integral of both sides. The integral of dy is just y, and then the left is that integral. How am I going to do that integral? Well, you should realize that that's going to be a problem because we've got a quotient with a product, which also creates a chain. So we can use the log rule, which is the following. Blah, 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 blah. Okay? So I started by choosing the natural log of x to be u, which gives me 1 over x, and then solving for dx, I get x du, which is good because it will cancel. And therefore we get down to that, which is fairly bizarre. We get the natural log of the absolute value of the natural log of x. That's where it comes from. However, if you're a memorizer, you can just memorize that formula. It's entirely up to you. This is not a very common function. I would lump it into the same category of the absolute value of x over x. You remember that one, right? Lucas, what's the absolute value of x over x look like?
Like a line that breaks at the point at movement.
Yeah, that's the one that goes to the right off of 1 and goes to the left off of -1 with open circles on the y-axis. This is a similar thing. When that x natural, 1 over the x natural x, let me try that again. When the integral of 1 over x natural log of x shows up, you can derive it using the same method I did using a u du, or you can just memorize the formula. It's entirely up to you. Some people function better using one of those different techniques. Okay, now we get to the big 6. Some of them we know already. What's the integral of sine? Negative cosine. Does anybody actually use that stupid golf thing I showed you?
Yeah.
Yeah, okay. So the integral of cosine is sine. And then we have all those other bizarre ones. What we want to do is be able to find the integral of each of the 6 big trig functions. So we know sine and cosine already. We want to know tangent, cotangent, secant, cosecant. I'm going to show you where one of them comes from. In other words, I'm going to derive it just like I did on the last one. But honestly, most of you are just going to memorize all 6. Or memorize the other 4 because you know the first 2. Okay, so I want to find the integral of tangent. Who's it there? Eventually we'll get to a formula. But suppose I asked you to do this. What would you try?
Splitting into sine and cosine. Just do the integral.
Good. Then what, Luke?
U du.
Which one? What would you like u to be?
I mean, it could be either one. but
Cosine.
Go cosine.
You want to go with cosine, or because he's bullying you into going with cosine?
No, I was gonna say cosine.
You were, huh?
Yes.
Okay.
Otherwise you'd get a negative.
I'm sorry?
Otherwise you'd get a negative.
Negatives are bad?
Yes,
They are.
they're negative.
Strangely enough, I also chose cosine, Luke.
How strange.
Yeah, weird, isn't it? Look, I get a negative.
Great minds think alike.
That's a pretty big leap there. I meant, that was
I know.
self-deprecating,
I
I wasn't good. I wouldn't do that in front of her group, I'd wait till it was just nine.
Can you go back? That went really fast.
Sorry. I didn't do anything, I just rewrote it, told you I was gonna make u equal to cosine. If u is equal to cosine, the derivative of cosine is negative sine. So as mentioned, as Mason mentioned, or mentioned Mason, we'll have a negative sign out in front. And it reduces to this nice simple function of the opposite of the integral of 1 over u du. Which by now you should all know is what? Again, I expected kind of a resounding answer there, but
Gonna be MS equals.
Negative, natural log.
it doesn't have to be if you're all synchronized.
That would be really weird, like a high line.
Would be negative one.
Make the AP test a lot stronger, wouldn't it?
Yeah, you have a little curve.
As long as you're at the top of the curve, who cares? Right?
Why are you yelling at me?
Oh, yeah.
Okay, so we get to that. So now what you know is that the integral of tangent, and just plain old tangent, is the opposite of the natural log of the absolute value of cosine of x plus c. Next on the list would be the cotangent. Luke, how do you think you do the cotangent?
Split into sine and cosine again.
Beautiful, then what?
U du.
Uh-huh,
Maybe with sine.
uh-huh,
And then just plug it into that and do the same thing.
uh-huh. Okay, so that would give us cotangent. Let's move on to secant. How would you do secant?
1 over sine.
Uh-huh, then what? Uh-oh.
You can't really do u du.
Here's what we do to solve the problem. We just click and it's right there.
Oh. That's genius. I should have thought of that.
I've been doing this a while. You should know the top two. We derived the tangent. Luke told us how to derive the cotangent. And then the other two we cheated and just clicked. That sounds good. Taylor, where's your phone?
It is in number 4.
You're right. We were at number 3. In your own mind, or?
Yeah.
No, Lucas is number 1.
In my mind, this is not that.
Is that yours in 2?
Anytime you'll always be number 1. To us at least.
Look, you dog.
It did.
I give you permission. You got my phone with you.
Just wait until next time he's absent, then you just comes back.
What am I looking at?
Do you not see that? It's like the week before final.
Oh, what happened? Now I see it.
Mr. Panini through it.
This is Mr.
Panini. No. What's up, Marty?
You work at Panera?
No, one day at lunch I was eating food, he said Mr. Panini, and everyone says that.
It's not very fair.
White isn't fair.
All right, we're done. That's day 76. So, according to the schedule, and by the way, the, yeah, because we skipped a whole bunch of days because of the final. The schedule online is accurate up through the end of February. Now, as I mentioned earlier, and you may have forgotten, we will be having a day 100 party. The way the schedule is currently set up is that will happen on a Friday, which is good news. However, on your schedule and on your assignment sheet, there's a quiz on Thursday. Grassy was just down here talking, we might move that quiz to Friday and switch Thursday and Friday. We're not gonna add an extra day, we just might switch the days. I will let you know ASAP. Molly has a question.
Am I gonna be here Friday?
I'm saddened by that information.
Can I take it Thursday?
We'll work it out. Okay, anything else? We're good? Let's start, no, let's make this the end of the lesson, and then tomorrow we'll start by wrapping up the 5-1 homework and answer questions about that, and then go over this homework, and then I think we're moving on to the second day of 5-2. So no new lesson tomorrow, so that'll give us more time to talk about homework. Okay, we good? Awesome, knock yourselves out.